Good morning, everybody. Here we are, Organic Chemistry 2, looking at retrosynthetic analysis towards a trisubstituted aromatic compound. And we left you with this example from last week. And we need to do some analysis on it to see what our strategy should be towards making it. Let's look at the groups that are on there and what their current directing abilities are. This group down here is a meta director, but it comes from an aniline. I take that back. It doesn't come from aniline at all. It's just a meta director. I was thinking about the Cyano group. I'm going to save that comment for later. The sulfonate comes from sulfonic acid, which is a meta director at all times. And this one here, whoa. Looks like I can't grab that comment. It's okay. Meta director, we're talking about this group here, the cyano, but it comes from an aniline, which is an OP director. OP, orthopara. And we have an alkyl group. I want to be a little more specific than that. So here we have the meta director. Here we have an alkyl group which is an orthopara director. But it came from a meta director. We had to have a carbonyl there first. So we have some flexibility here. We have flexibility. Let's talk about putting groups on first and where the next group would go. Remember, you're going to start from benzene. So if I start by putting the precursor to the nitrile, which would be the aniline, then the question would be, if you have an NH2 at this position right here, where would the second group go? So pretend all the groups are off. You're starting from benzene. You're putting a nitro group on first because we've been reviewing and we realize the only way to get an NH2 group is from a nitro, which is a meta director. And then you can convert it to an NH2, which is an orthopara director. And then I have feelings of contentment because I see, relative to this position on benzene here, I have two groups. One is para. I'll put that on second because para is major once I have the NH2 on there. And the other group is ortho. So right here, I have a strategy for my whole synthesis. I will verbally outline other possible strategies. Keep in mind that this is an orthopara director, which would be good to put this group on, but it came from a carbonyl, an acyl group. And the specific acyl group would be this one. And that's a meta director. I put that on first, then I could put my sulfonic acid on. Then I could reduce this to the orthopara director that you see right now and put this group on. I also like this strategy. So I don't know which one I like better because they're both going to get full credit. I'll go with the one I just talked about. And I'm gonna start with benzene. And this is a time where you can fool the teacher. So do the forward synthesis over here. There's your benzene. I've worked out my strategy. I'm going to put the carbonyl on first. And that's going to be using this, which I'm going to have to manufacture from an alcohol. Not a big deal. And aluminum chloride is the catalyst that gets that onto the benzene. I'm working on my forward synthesis towards my target right now. Don't tell the teacher. Now I have a group that's a meta director. I look at my target. Meta to this isobutyl group is the sulfonic acid derivatives. It's a sulfonate. That's just acid-base chemistry to finish that. We'll do that at the end. And I'm going to put a sulfonic acid on there. H2SO4 and heat. And that will put a meta sulfonic acid. And what we have here is an SO3H down here. And we have our ketone up here. And so we have that. And now I need to get a group here, which is impossible with the current situation of having a meta director here and a meta director here. Your next group will go here unless you alter one of these two. And I have to do that by making this into a carbonyl. Sorry, it is a carbonyl, by making it into a CH2. I need to reduce this to a CH2. Look, it's a CH2. And you got two choices. And I'm going to tell you right now, one is a little better than the other. The two choices being Wolff-Kishner, which employs a base. I'm not happy about that choice. My base will be consumed with my sulfonic acid down here. I'd rather use the acid version of the reduction, the Clemenson. And that involves zinc, amalgam, and HCl. And we create our isobutyl group, which is in our target. Isobutyl. And the next group will go para to the isobutyl as major. That's this position. I like it. And we get a little ortho product as well. Remember, when you have two groups on benzene, one being an activator and one a deactivator, you can pretty much ignore the deactivator and do your predictions based on the activator, and it's an ortho para director. The next group wants to go here for major, and that's what I like. And how do you get a cyano group on benzene? That's a question. That is a complicated question. It's a multi-step process that involves, here's the clue, it comes from an aniline. Well, you better get an aniline on there first, or else you can't make it into a cyano. You don't know how to put an aniline on benzene directly. You know how to put a nitro on benzene. And then you better learn how to reduce a nitro to an NH2 before this next test, or else this next test shouldn't be in your future. It is one of the principal tenets of this test to reduce nitros, which I'm making right here, NO2, NO2 to NH2s. And we'll work on that in a second. And how do you get a nitro group on benzene? We better know. You'll be doing this multiple times on the test. And there's your nitro group, NO2, nitro. You must know that as well, that it's called that. How do you reduce the nitro to an NH2 so I can make my target? We're going to be making our target shortly after we make this intermediate right here. We have an IBU right here. We have an SO3H here. And we have an NH2 here. How does one do such a thing? The safe one is H2 and platinum or nickel, one of the two. That won't reduce any of the other functional groups here. The isobutyl's already reduced. The SO3 can be reduced, but we're not going to even study that in this course. And this will take NO2 to NH2 if you're lucky in the lab. And then we have we have to do a lot here, which means I need even more room. There we go. There's a lot of things involved here. We have to do the process that makes the diazonium ion first. That's N triple bond to N right here with a plus charge on the middle nitrogen. And that involves using those chemicals we studied at the end of last week. Step 1, NaNO2, HCl XSAQ. (0°C). Yes, I will be grading temperature on this particular reaction, because if you don't use 0°C, you have just put a phenol in this position, an OH on this position, and that is not what you want. And step 2 is going to be KCN, CuCN. And you need to warm it up to room temperature. And step 3 is to get rid of your carboxylic acid, your sulfonic acid. My apologies, sulfonic acid, and make it a sulfonate anion. NaOH will work, sodium bicarbonate will work, any base at all will work because it's a strong acid. It's not going to take much to take its proton off. So there's a lot of stuff there, and we're not done. Sadly, I have all this room in the middle of my page I didn't take advantage of. Let's do that now. I need to make somehow, some way, I need to make this acid halide from this alcohol. And that's 4 carbons. And how do you do that? That's not a one-step process either. That's 2 steps. Acid halide is a carboxylic acid derivative, can be made from a carboxylic acid. First step, oxidation to a carboxylic acid. CrO3 H2SO4 AQ. And then our favorite SOCl2 and pyridine, the reaction that never goes away. And you've made your acid halide. And then we've got to convince the teacher we thought backwards through the whole thing. Let's do our retro arrows, saying, yes, we knew all along we wanted to go from here, from this guy down here. And this came from this here. And the one on the left came from this one on the right. Retro is getting a little funky looking here. And yeah, that does look weird. And this one came from here. And this guy came from up here. And that's benzene, so you're allowed to stop with that. And this came from here. So on this test, you can do the forward synthesis in your mind and then put it on paper, as we did here, and then retrofit it. You like that? Retrofit it with the retro arrows. And this is not the only strategy that would get 100% credit on this question. The other one I outlined earlier, put a nitro group on benzene first, convert it to NH2, and that would be an NH2 right here. Pretend there's no other groups, just use your mind right now. Start with benzene, put an NH2 group right here. What's your next group going to be if you have an NH2 group here? Para major. I want to put the carbonyl on here. This same protocol to get the carbonyl on here. Then I'll have what's an ortho para director and a carbonyl meta director. Hey, win-win. Your next group has no choice. There's no major or minor about it. It's going to go ortho to this and meta to the carbonyl. Your next group's going to be a sulfonic acid. And after you've done that, the NH2 gets diazotized and then cyanized with KCN-CuCN. And then once again, you have to deprotonate your sulfonic acid. So yeah, another strategy for full credit. You only have to show me one strategy for full credit. And that is the end of our retrosynthetic analysis. That would be a nice little segment all by itself. And I think we're going to call it right there. And I will be back very shortly.